over the last couple of days. So I'm not going to go too much. We'll start Murat. It's all you.
Thank you,
Take it
Michael.
away.
Hey, my name is Murat Karslioglu. I'm the Director of Storage Systems at Nexenta. And most of you guys were on the previous session watching 7 industry leaders trying to define software-defined storage. This is why we need software-defined storage, because people are not good at defining complex things. So if I ask, where are you, Michael? How is your relationship with your girlfriend? He would say, complex. I can't define it, right? So today...
My wife would disagree.
No, I asked girlfriend. Okay, and this is why we need software-defined storage. And as Nexenta, we have done some, probably the world's first solid software-defined storage implementation. And actually, the simplest way to define software-defined storage, probably you guys don't remember all the definition from the previous session. Software-defined storage is storage defined by not human being. So if you were in Nevada, you would call it maybe alien-defined storage, but Silicon Valley, there are more software engineers than aliens, so we call it software-defined storage. It's easier. And also, as human beings, we always make mistakes. We have engineers in the room, and we deploy in our engineering and deployment development environment. We deploy Nexenta Store every day, tens of times. And once in a while, we are the Nexenta Store experts, but we fail to configure it correctly, because when you are under stress, when the expectation is high, you miss some fine-tuning parts. And what we have done, we took VDI as a use case study, and we developed a solution, world's first solid software-defined storage solution to improve and simplify the provisioning process in VDI deployments. So key takeaways from the session today: how we remove storage from VDI admin's plate. Because as human being, we always make mistake. You need to remove provisioning part from storage admin's plate. And how to get more, and this will be a solid example to see with and without software-defined storage improvement, how many percentage we can improve the performance between STS and non-STS case. We picked an affordable branch office server. Probably most of you guys have a better server in your garage than this one. So 48 gig of memory and single 6-core processor. If you are familiar with VDI deployment, this can not be considered as a platform to deploy VDI, because it's really low resource server. 6-core, 48 gig of RAM, and only 3 HDDs. One was taken by ESXi host, and that gives us only 2 HDDs, not even SAS drives. So what can you expect as far as the VDI performance? So you can only go up to performance of 2 SAS drives, right? And we looked into the challenges in VDI world, because as an IT admin, so storage is expensive, and again, it's too complex. We cannot, as a human being, we cannot define it. And storage performance in VDI world, and what we see from our customers and what we hear from VMware, 60% of the VDI deployments fail due to some storage miscalculation. So as an IT admin, storage admin, if you have budget, you either over-provision it or you under-provision it. If you over-provision it, cost goes up. If you under-provision it, performance goes down. You need to be on the fine line, and you need to be an expert. And there is no way, if you are under pressure again, obviously you will make a mistake, and you will end up with a failed POC. And this is the storage guessing game today without STS. When you have a VDI environment, you have the broker, you have the hypervisor, physical servers, and you have a monolithic shared storage. It's a mess, complete mess, so massively expensive storage system. And what we have done, we integrated storage into VDI, and we automated the provisioning process. This is really solid software-defined storage project. And what we have done, we removed all the necessity to guess what kind of storage performance you need. And we end up with our new product called MV4V, Nexenta VSA, for VMware Horizon View. To give you an example, this is the real high-level architecture. Orange pieces are software-defined storage pieces that Nexenta provides. We have a management appliance running inside the management cluster. What it does is it's actually the brain of the software-defined storage. So it decides for you, and you just define your simple requirements, like how many desktop do you need? That's all you need to know. You don't need to be storage expert. You don't need to be network expert or VDI expert. This is all I need to provide. How many desktop do you need? Let's say I need 100 desktop, and our appliance, software-defined storage appliance, goes and decides based on some complex algorithm that human can always make mistake. Software complex algorithm, it decides what kind of storage resources you would need and what kind of resources you have available, and provides the storage for you. So it provides the storage on that fine line, not over provisioned, not under provisioned. So it deploys our Nexenta store, or can be a third party. We also support third party NAS. It can be also deployed on EMC NetApp. And this is the process how we automate it. So we have the management server. This is the brain of STS. And you have ESXi cluster. We communicate with the SDKs, VMware SDKs, could be Citrix, could be some other vendor, but this is a POC. This is the product we have now. Then the Nexenta agent runs inside the View connection server that creates the communication, handles the API. And what it does, it gets the requirement from user, which is just simple step. You can see it on our website, on YouTube channel. You provide how many desktops you want to deploy. Again, 100 desktop, and I want to name it a demo. And on the background, our STS appliance goes and creates the network, deploys Nexenta store as a virtual storage appliance, and creates VMDK's virtual drives on the ESXi host and mounts them back to Nexenta store. On top of it, it creates a pool, then NFS share, and shares it out back to the ESXi host. So this is all on the background, automated, really fast deployment. You don't need to provision storage first. So your necessity, your requirement is just number of desktop. You don't need to know more than that. And our STS appliance, that brain, goes and communicates with View connection server and deploys desktops on top of the newly provisioned virtual storage appliance. This is exactly what 7 industry leaders were trying to explain. And then we communicate with the desktop agent and run benchmarks on top of it. So you don't need to read all of that. Just to simplify and give you an example of how many steps are required. Reality, including the storage deployment, there are over 150 steps that a system admin or storage admin or IT admin, network admin combined needs to decide, and goes through 150 steps. If it was 2 steps, your chances of making mistake 50%. But if you have 150 steps, obviously you are going to make some mistake at some point. And these are the high level of those steps, just reduced to 23 main sections. All are defined, all are predefined inside the STS, and based on some long years of research, we know what kind of workload VDI generates. And we decided for you. So that appliance, software-defined storage appliance, decides for you, and you don't need to guess. Again, we remove completely that guessing game from VDI plate. And here are some numbers with and without software-defined storage. I'm showing you this because obviously this is a solid proof of software-defined storage, how it can improve your life, not only life, performance, and end-user experience. We run the test on the same platform, same 6-core Intel-based 6-core CPU with 48 gig of memory. Without STS, if a system admin, so storage administrator, goes and configures manually on local disks, you can only get on the left-hand side, on local disks, you can only get 18 desktops deployed on the same platform. If you let STS deploy for you, because STS is smarter, it knows how storage acts, what the requirements of VDI are. And we were able to get up to 55 desktop on the same platform. This is a huge improvement, 3x improvement. Doing what? Doing just using STS. There is no other storage component add-on, no SSDs. Using the same limited hardware, 3 times improvement. And by the way, these results are certified by industry-leading VDI testing tool called Login VSI. And on the right-hand side, you see the end-user experience. By end-user experience, I mean the IOPS that you get per desktop. When you deploy without STS tool, just human being, you get around 120 IOPS per desktop. But if you let STS fine-tune it for you, we were able to get over 42 IOPS. Actually, that left should be 12. Yeah, 11. So without, sorry. Yeah, on local storage, 11 IOPS versus 120 IOPS with same amount of desktops, but if you bring the number of desktop up to 55, we get 42 IOPS per desktop, which is total IOPS is almost 11 times better than non-STS use case. And how do we do that? Of course, there are many complex algorithms and many complex components on the background that does that. We define and we fine-tune how the compression works. We use compression. We use some caching, ZFS, main ZFS technologies like ARC, L2 ARC, ZIL, and other ZFS benefits that human cannot manually fine-tune. And also we see some improvements on cloning, on deployment time, up to 5.4 times faster deployment and up to 8.5 times storage capacity saving. Again, this affects to your per desktop cost dramatically. And what we see based on the testing, so STS completely removes the storage guessing from admin's plate. That helps you to improve your performance dramatically because the configuration is predefined and tested many times. We know STS, your STS appliance knows how to configure the storage for you. You don't need to make the same mistake again and also over provision or end up under provisioning. And here are some workload statistics from vSphere, and this is without the STS piece. So we try to deploy 55 link clones on the same hardware, and when we get to, and our threshold is usually you put a threshold around 90%. If it goes over 90%, you overutilize the CPU and system keeps freezing. So we put a 90% threshold. When we were around 18 desktops, the CPU utilization on the same ESXi host was around 88%. And we couldn't get more than 25 desktop. Sessions started to drop and desktops became unresponsive. If we let STS, when we let STS do its job, so we were able to get 55 desktop. You can see the CPU utilization on the left. Not even going over 90% CPU utilization. You could probably deploy more desktop if we had enough memory available on the platform. With 48 gig of memory, 1 gig assigned per desktop, we were actually over provisioning memory, but performance was still good. And this shows actual login VSI numbers, so baseline and number of desktops. This is actually certified by industry-leading VDI benchmarking tool. And for heavy workload, the difference between medium and heavy workload, as many of you may know, medium workload is a regular office worker using browser, Excel, Office, PDF, watching YouTube videos, as all of you do. And heavy workload had some additional application, heavier application running inside your VDI environment. And similar results. So when we have with MV4V, we were able to actually get up to 40 desktop, which was already higher than medium workload without STS implementation. And this is another proof that shows the CPU utilization during a 1 hour IO-meter test. CPU never spiked, always stable. And this is the end result. So, and my last slide actually, as you can see, we had only 2 SAS drives on that platform. And after deploying 55 desktop, we ran some disk benchmarking utility on one of the desktop, while the other desktops are running IO-meter. And the result is above impressive. So we compare that tool called performance test, is an industry again standard tool that people use to benchmark SSD or disk performance. And if, as you can see, standard Samsung or Intel or Seagate drives performance, single drive performance around the maximum is, the best one is I guess the Seagate on top. No, that's the worst one. Yeah, Intel closes Intel SSD and getting around 3,500 performance test number, and we were able to double it just by using 2 drives, but running 55 desktops on it. So actually, STS can turn your slow regular SAS drive into a drive faster than SSDs if it's fine-tuned. Thank you, everyone.